Using the cosine rule to solve a harder application problem. Remember, our cosine rule states that c squared equals a squared plus b squared minus 2ab cos c. It's important that you understand when to use this. So if we want to solve for side c, we need to know the angle opposite. The two shorter sides, or the two other sides here, a and b, make that angle c. In this application problem, let's consider a two-legged journey. We've seen a couple of these. So here we see that the distance of the first leg of the journey is 12 kilometres, and it's on a direction of south 30 degrees towards the west. Or we could think of that as 210 degrees true. Before we put our second leg of our journey in, it's important that we draw another compass. Now I've drawn in a second journey. So here I see the direction is north 45 degrees towards the west for a distance of 7.5 kilometres. So the question I want to do now is, how far is it for the walker to return back to their starting point, and what direction do they have to travel in? This style of problem is a classic cosine rule problem, and it's important to understand why. Whenever we have a problem that involves two legs, so here we have the first leg and a direction, then a change in direction and the second leg, we can always calculate or determine the angle between those two legs. Here, using alternate angles, I can see the 30-degree angle here from the vertical to my first leg is equal to this angle over here from the vertical to my first leg. So I can see here that the whole angle between these two legs is 75 degrees. So now I've got the condition side, angle, side. So I can use the cosine rule to find the length opposite the 75 degrees. So substituting in, I have d squared equals 12 squared plus 7.5 squared minus 2 times 12 times 7.5 times the cosine of the angle between them of 75. Solving for d here gives an answer of 12.4 kilometres to one decimal place. Next, I want to determine what direction they have to travel in to return home. This means I need to put a compass at this position here. Before I do any calculations, I like to determine what the bearing will look like. So here I see it'll be north, this angle that I'll call theta, towards the east. It can be quite tricky to find this angle, but the first step will always be to find the angle in the triangle next to the angle you want to find. To show that more clearly, I'm going to draw that triangle again in a clean space. So here's the triangle again, and I want to find this angle here. So I need to think about what rule I'll use to find that. I see that I know the side lengths of all the triangle. That means I can use the cosine rule to find this angle, using this is angle C and this is side C. However, I also see that I've got an angle side pair, which means I can use the sine rule. I prefer this approach, so let's use the sine rule here. There's angle A and side A, angle B and side B. Here's the sine rule, and substituting in, and now taking the inverse sine. Now this gives an answer of 69.2 degrees. Let's go back up to our original diagram to see how this helps determine the bearing. So here we're back at our problem. I've put in the 69.2 degrees we just found. So to describe our bearing of north theta degrees towards the east, we're going to have to do another calculation. So at the moment I can't find theta because I don't know what this angle is in here. However, I can use the 45 degrees down here and alternate angles to see that the angle in here is also 45 degrees. Now I can see that these three angles, the 45 degrees, the 69.2 and the theta, make up 180 degrees. So now I can calculate what theta is. Therefore, the bearing they must travel on is... This is most definitely one of the harder problems you might face on a test. However, looking back at the steps, drawing out the two legs of the journey, we can always find the angle between those two legs. That sets us up to use the cosine rule to find the distance d. Describing the direction, perhaps from their final position back to their start, requires us to put in a compass point at that position, and then we need to think about how do we describe that bearing. The next step will always be to find the angle in the triangle at that position, and you can choose the cosine rule or the sine rule generally to solve for that, and then the alternate angles generally pops up again. An example of one of these is on homework number 3.